Ryzen 2000 has launched, and we've been hard at work poking and prodding it and seeing what it has to offer, unlocking its secrets. It doesn't make the Zelda noise when you unlock it though. But we've got an interesting story, and it's going to be a long one. At least it's interesting to me. Ryzen 2000, sure, it's an incremental update. You know, these second generation processors are what's called Zen Plus. And so really, this is just a refinement of the first generation Ryzen CPUs that came out last year. You know, Zen was a big deal. I mean, it's new chipset, new CPU, new microarchitecture. It's crazy to do all that at once. And Zen was a very, very ambitious project in general. I mean, not just a product. And we've got new motherboards and new chipsets this time around. You can still mix and match CPUs on AM4 just like AMD promised, but you also get some perks with the new X470 boards. Perks like seriously fast memory. That's a huge improvement over the last generation of boards, especially because Ryzen's performance can improve pretty significantly with any uplifts that you can do to memory speed or decreases in latency by clocking the memory faster and that sort of thing. So to be clear, yes, you can totally use a 2000 series Ryzen CPU in a first generation board. The the Ryzen 2700x though, I would caution you, that's a 105 watt CPU. We've seen it use power up to 140 watts. I would caution you not to put that in a B350 board or a first gen X370 board that might have a questionable VRM implementation. If you got a high-end X370 board, you can totally do that, and that'll totally be fine. For the other CPUs, it doesn't really matter as much because those CPUs don't use near as much power. But if you want the flagship CPU, it's probably worth it to get the perks that you get with the extra boards. Not just the memory speeds, there's a lot of other things like Store MI. We did a separate video on Store MI, you should check that out. There are other little perks too. Well, if I could interject there for a second, I mean, if you've got a great first gen board like the X370 Gaming Pro Carbon from MSI, or the ASRock Taichi, or the Gigabyte Gaming 5, or another, a higher end X370 board, on those first gen boards with first gen CPUs, we were seeing DDR4 3200 basically at the top end, maybe 3000, 2933 is a little bit more stable, and mixing and matching the second gen CPUs with the first gen boards, it doesn't really seem like the situation's improved. If anything, maybe it's regressed a little bit. This is anecdotal testing, it's not formal testing, but it does seem like 2933 with those second gen chips is a little bit more stable than the faster speeds. So it's also true that it's kind of diminishing returns past 2933, past 3200. I mean, if you can tighten the timings, often you're better off than the higher clock speed anyway. Because when you increase the memory speed, you're pushing the Infinity Fabric and that whole thing plays into it. So you can mix and match CPUs, but it does seem like you get a better memory speed on second generation boards. But of course, diminishing returns past 2933 or 3200. So just, weigh that for what it's worth. All right, I'll let you get back to it. So we're seeing one big improvement, one obvious one, and one not so obvious one that's a little bit spooky, and one that AMD hasn't really mentioned, but that we've experienced personally. And that's why I say this video is going to be a little longer, a little more difficult for me to explain. But first, for the quick and dirty. Yeah, give it to me straight. I don't really care about all your egghead nerdery. I just want to know, give me the bottom line. What's up with this? All right, the 2700X versus the 6-core Intel i7-8700K. The 2700X holds its own. We're basically at parity with Intel. There are certain scenarios where the 2700X will outperform the Intel i7-8700K. Yeah, I know, shocker. And there are certain scenarios where the 8700K will be marginally faster. We're talking 1080p gaming and 1440p gaming mainly. 1440p and 4K gaming tend to be more GPU bound than CPU bound, so there's honestly not much difference between these CPUs for gaming type workloads. And the AMD fanboys right now are like, yes, we're, AMD master race, everybody wins, AMD better than Intel, woo! But that's not, come on, nobody needs a fanboy. Both CPUs are seriously impressive pieces of engineering. They really are. And they're different critters. They approach problems in different ways. AMD's approach is very pragmatic. I mean, honestly, the ragtag underdog of awesomeness is able to do, unseat the giant behemoth. It's any kind of David and Goliath story, no matter how you want to cut the cheese, but it's actually a good product. Like, just set all that aside. I don't have time for that. I don't care about the backstory or anything. I just want something that works. a good product, does really well. And it does even better than Intel in things that aren't gaming, which we'll talk about in a second. So where did the gaming performance improvement come from? I mean, the gaming performance on first gen Ryzen was there, except in high frame rate games. And it was really hard for first gen Ryzen to deliver, you know, that 150 FPS plus gaming experience. So this is thanks in large part due to improvements in the latency on the platform. And so what are we talking about when like, what do you mean latency? So we've got the level 1, the level 2, and the level 3 cache memory. Level 1, get it? There's memory that's on the CPU, that's really high speed memory, that's really close to the computational mechanism of the CPU. And the data that the CPU is working on is stored there because system memory is too slow, because literally everything else in the entire system is too slow. And level 1 is insanely way faster than level 2, is insanely way faster than level 3 cache memory. And then your memory, like the system memory, the DDR4 memory, is just glacial in comparison. The level 1 and the level 2 cache memory are operating on the order of nanoseconds. I mean, the level 2 cache memory is typically like 12 nanoseconds or 12 cycles, or, well, 12 cycles, which is actually less than 12 nanoseconds because the clock speed's faster than 1 gigahertz. So anyway, it is just a massive engineering accomplishment that AMD has been able to do that. I cannot overstate that. It is mind-blowing, and it's really awesome. And it's really awesome that they've been able to improve that between Zen and Zen Plus. I thought sure that it was gonna be Zen 2 before that was really improved, because we were seeing, you know, the benchmarks for the first generation Ryzen. It's really awesome to see that that is fixed, because holy cow, those fixes basically fixed a lot of other stuff, as we'll see in just a minute. So story time. It's benchmarks, you know, it's all about the benchmarks, right? Well, not so fast. You know, we had a mystery on our hands when we were benchmarking the 1000 series Ryzen CPUs. There was some stuff happening that didn't make sense from a computer engineering, from a computer science standpoint, and it's not really an easier, cleaner way to explain that. That's one of the reasons why this video is kind of going to drag on, but hopefully the story is interesting. So there are a ton of benchmarks around the web, and we're not really super good at benchmarking yet. I mean, we try, but we, the people, not we level 1, have got to get an automated and repeatable benchmarking platform, something to automate games, something to be sure that it's like, I'm gonna run this game benchmark with exactly the same settings and all the same stuff as, you know, a reviewer or as somebody else. Just one, to be sure that my machine's performing the way that it should be, in case I haven't missed something obvious. It's like, whoops, my memory is running at 2133. It's like I've had a brick tied to my head for all these years, and all I had to do was just turn on one thing, and it was gonna be a way better computing experience. There are people out there right now that are experiencing that. It doesn't have to be that way. We have the tools to make that better, I think. So, you know, I've also seen a lot of squabbling between and among the tech press, you know, about performance anomalies and game settings and all this kind of stuff. And, you know, life's too short for that. It doesn't make sense to get all worked up about that. And synthetic benchmarks are also kind of annoying and not very good. What we really just need are repeatable benchmarks from actual, like, real world using an application. This is going to help buyers verify their systems are working and performing like they should. And not just with games. I mean, you know, there's things like the Phoronix test suite, which is really good. It's supported on Windows now. I've used it on Linux for a lot of our videos. That works pretty well. So think about something like that, but on steroids, and lots of well-maintained tests. Now, the spooky thing, I mentioned the spooky thing. What's the spooky thing? It's like, well, the memory latency discussion kind of leads into it. So you might recall we did a lot of GTA 5 testing last year, like just a crazy amount, because we're gluttons for punishment, I guess. And when we tested the first gen Ryzen, we noticed something weird. The experience when playing the game was better, but the frames per second was lower. And so we had a lower FPS, but playing the game was actually a better experience. That's kind of weird. We did a lot of testing, and we did a lot of high-speed footage, and so what we figured out, or at least our guess, we're pretty sure, was that the game engine spazzes out past 140 FPS. So like from 140 FPS to 187.5 FPS, the GTA 5 engine is exponentially more likely to spaz out, because the GTA 5 engine is basically garbage. Hypothesis. Why do we say that? Well, when we were testing on the first gen Ryzen CPUs, it just couldn't push above about 140 FPS. And the result of that was that it was a smoother experience than when we were testing on a 7700K, which would routinely hit 187.5 FPS. It was like it hit 187.5 FPS, and then it would just trip over its own shoelaces. It was pretty much guaranteed. But there was a chance that it would just randomly trip over its own shoelaces, even not hitting 187.5 FPS. It was really easy to see in the fraps graphs. It was really easy to see pretty much everywhere. And we did not get anywhere near that kind of behavior on first gen Ryzen. And that drove us crazy. We really wanted to sort of figure that out. So in other games too, like Fallout, the extra CPU horsepower really helped a lot. It really helps the game chug through some of the scenes and some of the situations where it needed a lot of CPU horsepower. I'm talking about first gen Ryzen here, versus the relatively puny 4-core 7700K of the era. And so it's like, why am I rehashing all of this? I don't really understand. It's like, well, the Fallout 4 engine was also pretty broken because it had a frame lock by default that you had to turn off and all this other kind of stuff. So unrelated, but kind of related, when we look at the benchmark data and artificial benchmarks like Firestrike, we noticed that the combined score was lower than we would have expected given the relatively high scores of the physics and graphics components of that test. Now, so that's just like GTA 5, where GTA 5 is a pretty CPU intensive game. So when we got the combined CPU and GPU stuff going on, you know, Ryzen just couldn't, the first gen Ryzen just couldn't push past 140 FPS. So it seemed like something was bottlenecking. And so that bottleneck, as it turns out, was likely related to that extra latency that we were seeing. So just a few extra cycles, just a few extra nanoseconds on every load and store operation was sort of limiting us, I guess. At least that's the current guess. So shuffling things between CPU and memory, but also I/O, sending packets down the PCI Express bus. The latency is higher than the system designer expected, I think, so that can reduce the effective available bandwidth. The Ryzen platform was new, you know, the Intel platform had a certain amount of latency in it. The Ryzen platform had a little bit more latency. Peripherals maybe not designed for that. Programs maybe not designed for that. So maybe some of what we were seeing was the extra latency in the platform sort of manifest as well. GTA just can't go past 140 FPS, and you get a smoother experience in GTA as a result because the game engine designers never figured anybody would have a system that can do, you know, that fast. I mean, Rockstar, for God's sakes, was probably designing for a console. It's like, oh, 30 FPS, you're doing pretty good. Yeah, am I right or am I right? Yeah, PC Master Race? I don't know. That was for the upvotes. So, so we couldn't 100% confirm it though. It's like, how do you confirm that? It's like, well, there are obscure NVIDIA driver options to limit GTA 5 to 140 FPS. And so at that point, the smoothness experience on both systems was identical. But you know, we couldn't close the loop there. Closing the loop there would be push the Ryzen system to 187.5 FPS or high, you know, some above 140 FPS, and see if you could get the glitching and the stuttering and all this kind of stuff. And we did, boy howdy we did. We had, for a day or two, we had the world record for the fastest single GPU 1800X system in Firestrike. Yeah, pretty nuts. And that part of the reason that we did that was to try to see if we could push through, you know, faster memory clocks and whatever. We did all kinds of crazy stuff. You just don't even know. And we could not get GTA to perform really well. So long story short, why did any of that matter? Why is that? What are you Ryzen 2000. That's what we're talking about in this video, Ryzen 2000. So with Ryzen 2000, this magically, insanely way better CPU, can we get those crazy high FPS in GTA 5? Yes, we can. We are in fact getting those crazy high FPSs in GTA 5. And does the engine break? Oh yes, absolutely. The engine just doesn't eat, like it just trips over its own shoelaces. It is pretty much at parity with Intel. So all of the game breaking weirdnesses and bugs, it's like you're flying with the jet and the benchmark and the whole game just stutters. Yep, that happens on Ryzen 2000 too, just as well as it, you know, does on Intel. Woohoo! I mean, I think that's actually a great result. There's no, like, these latency improvements have translated into real world performance improvements in pretty much everything. We've also been working on a project called Looking Glass. Now, Looking Glass is really exciting. This technology lets you copy the frame buffer from a Windows virtual machine to a Linux host. So it's very interesting for us in terms of how long does it take you to copy a 4K 32 megabyte frame buffer from that Windows host through shared memory, from the Windows guest, I'm sorry, through shared memory to the Linux host. How long does it take to copy 32 megabytes? If we can do it in a millisecond, that means we can do 1,000 FPS at 4K, assuming the system doesn't have anything else to do. But really we're shooting for like 60 FPS, so 60 out of 1,000 gives the CPU, gives the rest of the system a lot of time to do a whole bunch of stuff. And so we always look, how long does it actually take to do that? And to just give you a baseline, on our test systems, all of which have 3200 megahertz memory, the same G.Skill memory kit, thanks G.Skill, that's really awesome. G.Skill memory is like worked out super amazing. G.Skill memory with both of these, you should check it out, 3400, 3600, it's gonna be all part of our stuff, but I digress. So yeah, 32 megabytes. On the Threadripper system, which is the fastest system that we've tested this on to date, 0.8 milliseconds. So yeah, Threadripper has got the memory bandwidth. That is no problem at all. But 1.5 milliseconds on an i9, on a quad channel i9, that seems glacial in comparison. Why is the i9 so slow? Even at 3200, it makes no sense. So then we've also got first gen Ryzen systems, also about 1.5 milliseconds for the dual channel configuration. Womp womp, not very good. So memory speed beyond 2400 on the Intel 8700K doesn't really seem to make much of a difference. And it's at about 1.3 milliseconds, give or take. The Ryzen 2000 time, 1.1 to 1.2 milliseconds in our best case scenario. And that is running 2933 with really, really tight timings on the memory. So we've tuned the memory a little bit. We can get a much better or much worse time depending on what we're running our memory at. So again, memory bandwidth, memory speed affects the performance on Ryzen a lot more than it does on Intel. Now the really interesting thing about this, 32 megabytes is kind of a lot of memory to copy. And because the Ryzen system can do it faster than the Intel system, that suggests that a lot of the benchmarks do a lot of small operations really rapidly. And so when you do a lot of small operations really rapidly, maybe the benchmark program waits for that memory operation to complete, and then it does the next one, and then it waits for that one to complete, and then it does the next one. And so it's a little different critter than the way that it works on the Ryzen platform, because while the Ryzen platform has a measurably higher memory latency, when L1 and L2 are the same, when you talk about the layer 3 cache and cross CCX cores, and then maybe it might have to go do something somewhere else with a different memory controller, and then the memory actually getting stuff from memory. And we can measure those times with benchmarking programs like Ada64, and we know that they're worse. But for us, for Looking Glass, because 32 megabytes is kind of a lot of data, it sort of makes up for it, I guess, because Ryzen is better able to take advantage of the higher memory bandwidth. So even though the latency is a little bit higher, we can get stuff there faster. So think about, like, you've got to move your entire existence from New York to San Francisco, and you've got the car from Knight Rider, which can do 600 miles an hour, and you've got a straight shot from Elon Musk has dug you a tunnel. And so you can load up all your furniture in the Knight Rider car and do a lot of back and forth at 600 miles an hour from New York to San Francisco. Or you've got a box truck, and the box truck can only do 100 miles an hour, flat plank running down the highway, but it's a box truck. And so it's not really it's like a small box truck versus a large box truck. There's not really that much difference here in terms of speed. It's a little exaggerated. But for us, for Looking Glass, the Ryzen memory performance, because it seems to be better able to take advantage of the higher memory bandwidth you get from the higher clock memory, more so than Intel, it sort of makes up for the latency deficiency a little bit in that one particular use case. Now, it's going to be different from game to game. It's going to be different from this, that, and the other. But if you look at all the games benchmarks around the internet, they've basically closed the gap. And even for like oddball things like our Looking Glass project, the gap was closed and then some. So that's really exciting to see from an engineering perspective as well. So AMD with those bundled coolers, this is the Ryzen 5 bundled cooler. It's basically the non-RGB version of the same cooler that we saw with the Ryzen 7 1700 last year. Then we've also got the Wraith Prism, RGB that comes with the 2700X flagship CPU. Both of those coolers are perfectly fine, and as long as your case has adequate ventilation, you will totally see the on-the-box performance for both CPUs. You don't need to get an aftermarket cooler. So we say, and the Stilt agrees with us, that out of the box, the 2700X stock cooler can already perform exceptionally well, and manual overclocking will often hurt single core performance. So you really shouldn't do manual overclocking on the 2700X. And we can agree with that. I'll go a step further and say that if you do want to overclock, you can forget overclocking in the traditional sense, and you're just gonna have to let the CPU do its thing. And you're probably gonna need something crazy like an all-in-one cooler, like a beefy all-in-one cooler or something even better like that. Now in our testing with a good cooler, we say 3.9 gigahertz to 40, 50 megahertz on all core clock speeds. But we could manually overclock to 4.1 to 4.2 with a good all-in-one cooler, but we lost performance in 1 to 4 threads, just as we predicted. So AMD, I think, has anticipated this situation and given us more options for still letting us push past that limit. So, you know, the 4350 megahertz XFR2 limit, which is, you know, out of the box on your Ryzen 7, 4350 megahertz. You really want to try to hang on to that, and you can do that on X470 motherboards for sure. Maybe on X370 motherboards, it's really up to the board vendor to add support for that. Full support, maybe partial support, something like that. So you understand what's happening under the hood. The CPU is monitoring its thermal limits, its power wattage limits, and its reliability. So it's like 3 points of a triangle. It's basically keeping track of, you know, am I about to lose my marbles? Like, am I gonna have like a stress freak out? Like, you know, and just lose everything? What's my temperature like? And how much power am I drawing? Now, how it exactly precisely behaves, it's gonna vary from workload to workload. If you're doing something like running Prime 95, you're gonna see a much lower all-core boost speed, at least we did in our testing. But even for doing things like running Rise of the Tomb Raider, you know, we were seeing 4200 megahertz, 4200 megahertz across all cores without really, well, I don't wanna say all cores, it's like, you know, 4 cores. We're seeing it on like 4 cores. But when we did our, you know, customized super fancy overclocking, we were still able to get the 4.2 gigahertz all core when the CPU really needed it, as long as we could keep it cool, and we still got to keep our 4350 megahertz boost clock. So in the comparison with the 8700K, you know, can you overclock the 8700K and get back some more of the performance edge? It's like, you know, it's like level 1, you're telling me that they're basically at parity, but I can overclock the 8700K. And it's like, well, yes and no. When you overclock the 8700K, you're really just overclocking the core most of the time. You should also overclock the cache and other parts of the CPU. They all sort of clock independently. So when you add, you know, the 4.5 to 5 gigahertz, if you don't overclock everything else, it's really kind of diminishing returns. You can get a little bit of a lead, but in terms of stability, heat production, aftermarket cooler that you definitely will need because of the runaway thermals on the 8700K. I mean, you can, yes, that's not wrong, but would you rather just get a CPU that just, you know, you just plug it in and use the stock cooler and it already works great? So overall, you know, the 2700X, which is mostly what we've talked about, but also the Ryzen 5 2600X. The Ryzen 5 2600X, I think we're gonna have some separate coverage on that because it's an interesting CPU in and of itself. 6 cores, 12 threads. Short version is the 2600X is the value king. It's an almost unbeatable value because, you know, right in the box, you've got a good cooler that is more than adequate to keep that CPU cool, but this thing's gonna turbo up to 4.2 gigahertz or you know, XFR2, up to 4.2 gigahertz with this cooler, basically no problem. So great performance in games, great performance compiling, workloads, productivity, you know, content creation, whatever that you might wanna do. It's really, you can't beat the value. You just can't. I mean, even if you got an i5 and you overclocked the bejesus out of it, it's still the 2600X is gonna give the i5 a run for its money, and that's just what a time to be alive. Really, it's great. For the gaming benchmarks, we've got GTA 5, Rise of the Tomb Raider, and Civ 6. You know, as I mentioned, the performance is essentially at parity. The Intel test system is an Intel 8700K with multi-core enhancement on, so that's 4.7 gigahertz all-core turbo. So that's a little bit of an overclock in the Intel CPU in our comparisons. We're using ADATA DDR4 2400 dual channel with the Founders Edition 1080 Ti in all of our test systems. Now for our workloads that can actually take advantage of, you know, 8 cores, things really skew in favor of Ryzen. So I'm talking about, development, compiling code, working with databases, multi-thread applications, things like Handbrake. Ryzen, the Ryzen 2700x with its 8 cores, it wins hands down. We typically saw 40, 50 megahertz, only in things like Prime 95 that it dipped down to like 37.5, 3800, something like that, which is the advertised base clock on the Ryzen 2700x, but we almost, even in 8-core workloads, we almost never saw it actually operating at the base clock. Now, we did have the fan selector on our, Wraith Prism CPU cooler set to high, so the CPU cooler does get quite loud. Well, not quite loud. It's not as loud as a blower. It's not as loud as the Founders Edition 1080 Ti. It does get pretty loud. So, all right, based on all this, cut the nerdery. It's like, I don't miss that in my life. Based on my experience with the 2700X, AMD's claim of 5 to 10% performance improvement is true. There's some asterisks there, like if you bought, say, the Ryzen 1700 and overclocked the bejesus out of it, 3.9 gigahertz, 4 gigahertz, maybe 4.1 gigahertz on the 1700, it was the deal of the century. It was about $300. I think AMD has delivered on that value. I mean, it's a year later, and so we expect that 5 to 10% performance bump. But if you look at, we've come from the 1700 to the 2700X, better cooler, 4.3 gigahertz out of the box for, single, around 4.3 gigahertz dual thread workloads. Gaming performance is basically up there because they really have split the difference between single thread performance and multi-core performance. Now, can it overclock as much as Intel? No. Will it deliver an amazing experience nonetheless? Yes, it absolutely will. So based on my experience with the 2700X, I can say that AMD's marketing message of about a 5 to 10% performance increase is actually pretty modest. I think most users in most scenarios would definitely see more than a 10% performance uplift, especially more than a 10% performance uplift per dollar. The value of these things really is just, it's great. It goes without saying. Competition in the CPU market, the consumer wins. So this is, no matter which CPU you're leaning toward, this only benefits you, the consumer, because we've got real, actual competition in the marketplace. This is a great product. It does exactly what it says it does, and it does it well. That's all you can ask of a product. I think it's pretty good. I'd also like to give a shout out to Brad Morris for helping me crunch the numbers and do some analysis here, and also to Max CFM for helping me put the test systems together that we use in our testing for not just this video, but also a couple other videos, some of which are probably not out yet, and some of which probably already came out, like the NVMe RAID video. So kudos, thanks. I thought this video would come out first, but editing was tricky and the performance numbers, and we had to do some analysis, so I'm Whittle. This is level 1. You should like and subscribe and hit the bell or thumbs down if you want. I don't care. Just some sort of interaction to feed the algorithm, or at least that's what I'm told. So I'll see you in the forums at level 1.